Right, good morning. Feedback on the organic mock that you did last week. I'm going to do the multiple choice questions in one video, and then I'm going to do the extended questions in another video, but they're all together on the same document. Okay, so go through the multiple choice questions. Question 1 here, this is something you need to learn. You did this at AS. You just need to learn the test and know what the reagents are. How can this molecule be described? Some of you obviously identified this as aromatic, which it isn't because there's no ring in the middle. So it is a ring, but it means, so it's alicyclic, and it's also saturated because carbon is making all the bonds. This one could be a little bit time consuming, I think, in an exam, unless you recognise straight away. It's kind of a question that maybe you should move straight on from if you don't see the answer, and then come back to it, and if necessary just guess. Never leave a multiple choice question unanswered, which some of you did do. So really here we're looking to get a quick answer. We've got the same volume of gas, which means we must have the same number of moles, so this formula gives us the same moles of each if you think of the equation. Okay, so we've got 2 moles of carbon dioxide, 2 moles of water. This one, again, this is going back to naming from AS, naming EZ isomers using the Carning gold thing. So you have to identify the higher atomic mass for the atom, designate it 1 or 2, and then depending on whether they're on the same side or on opposite sides, so it would be E or Z. This one cannot produce a Z isomer because this carbon has got the same group on it. For EZ isomerism, your carbon must have different groups. Okay, but until you've designated them 1 and 2, you won't know which one is a Z isomer. Of course, once you come across it, which in this case is B, you should be okay. You shouldn't need to worry about the others. Which type of reaction has the greatest atom economy? Is always going to be addition, because you only get one product from an addition reaction. If that's the product you want, it's going to be 100% atom economy. Okay, shapes, again, this is going back to AS, isn't it? Shapes around molecules. So trigonal planar arrangement. Here we've got 1, 2, 3. Don't forget that double bonds and triple bonds are counted as one bond when we're looking at shapes. So carbon number 3 shows the trigonal planar arrangement. These are obviously tetrahedral, these carbons. This nitrogen you may think is trigonal planar, but of course nitrogen has a lone pair which squashes it together, so it won't be trigonal planar. It will be what do they call it? I mean, there's bent, or can't remember what they call it in OCR. Anyway, it's not the nitrogen. Secondary amine, obviously you need to recognise that both 2 hydrogens have been replaced on the nitrogen, and obviously you could be fooled by this one, but this is actually an amide, not an amine, so it has to be A. Chiral centres, I think the easiest way to do this is to quickly put in the hydrogens. Obviously if there's a double bond, you know that's not a chiral centre. So it's really looking at these carbons that you're not sure of. Okay, so if you stick the hydrogens in quickly, then you can see where the chiral centres are, and there are 4 of them. Molecular formula, again, you know, unless you're very confident, just put in the hydrogens and count it up. Very straightforward. Don't forget these have got carbons on the end. These are CH3s. Yeah. If we're adding the same amount of the 4 compounds to the same volume of water, which one would be the most acidic? The obvious, well, these 2 you can obviously discard. This is obviously basic, and this is an ester. This one, so obviously your eye is drawn to this one. It's a carboxylic acid, but of course this one will form, this is a weak acid, whereas this one will form hydrochloric acid because it's an acyl chloride. So it will form a strong acid, effectively. Okay, how many peaks on a proton NMR spectrum from this molecule? It's going to be 3, and I've numbered them because you've got a symmetrical molecule here. Number 12. Okay, you have to look this one. You're kind of drawn to that. You've got the same number of moles of each, and this one you think, oh, there's 2 OH groups, but actually, because this one is actually the limiting reagent as such. You can't make any more water than there are OH molecules, OH ions. Okay, I think I'm okay. I'm going to start my explanation of number 12 again here. Right, we're reacting these two together. Okay, this one has got 2 OH groups on it. This one has got 1. So you're asked how many molecules of water are formed. So you are limited by the amount of sodium hydroxide. You won't be able to make any more molecules of water. So you've got 0.1 instead of 0.2. You may think of doubling that, but you don't. So it's 0.1 moles times 6.02 times 10 to the 23. So the answer is A. Okay, we're looking to prepare an amide here. So you've got to look for the reagents that produce amides. An acid chloride plus a primary amine. It's a secondary amine. Amine, yeah. Sorry. Acid chloride plus a primary amine give us a secondary amide. Okay. Or amine. We've got rid of one of the hydrogens there. Okay, we're looking at the reaction of radical substitution to form chloroethane. Which radicals are present in this mechanism? I mean, this a hydrogen radical doesn't exist in this mechanism. So you've got your chlorine radical and your ethyl radical. Yeah. So you need to be familiar with the propagation steps of radical substitution. Structural isomers. So obviously, you just you've got to check the formula of these substances. They've all got the same molecular formula, so the answer will be all of them. Okay, so I'm going to stop the video here for the end of the multiple choice questions, and I'm going to do another video looking at the extended questions in section B. Okay.